The concept of the soul is one of the most debated and deeply personal topics in philosophy, religion, and science. While different cultures and belief systems define it in various ways, the soul is generally understood as the essence of a person, something beyond the physical body. Although science doesn't directly recognize the soul as a tangible entity, it does explore consciousness and self-awareness in fields like neuroscience and psychology. But today, I want to have a little bit of fun by theory crafting the paranormal with science. Today, I want to explore if there could be proof of something after our bodies die. And for this, I will be delving into discussions on biology, chemistry, and physics. And I forgot. Hello, my name is Florio. If you're new to the channel, welcome. Otherwise, it's nice to see you guys returning again. I just want to do a little bit of a disclaimer. So this show, I'm calling it, I guess, paranormal theory crafting. And the idea is I'm just throwing out some theories and ideas that relate back into science. So like paranormal science theory crafting. And I want to link it back into scientific theories and methodologies and things like that, just for fun. I'm not trying to prove anything. I'm not even saying that these things are even proved. Like a lot of these theories that I'm going to talk about are interesting and people are still looking into it and there's no proof of these things yet. I just think it is an interesting topic and I just kind of want to discuss it with you all. So that being said, don't take this video seriously or literally. I'm not trying to prove anything. I'm just throwing out some ideas that I thought were kind of cool. And yeah, I just want to have a bit of discussion around it. So for today's video, what I'm proposing that we discuss is the idea that our soul may be the electricity that powers our body. After all, science says energy cannot be destroyed or created, only transformed. So before we get into the physics of energy, let me first explain the energy that our body produces. The body's energy. Your brain runs on electricity. Billions of tiny sparks firing every second. It's what makes you who you are. Every thought, every movement, every memory. It's all powered by tiny electrical signals. But how exactly does this work? How does electricity flow through the brain, and what does it mean for the way we think and feel? To start, let's go back into the 1700s, where Luigi Galvani of Bologna made an unusual observation of disembodied frog legs that were hanging on copper hooks from an iron balcony. They would sometimes twitch as if they were still alive. From this and subsequent experiments, he deduced that electricity, rather than the widely accepted idea of spirits, was the true force driving the nervous system. Since then, science has vastly improved its understanding of the body. At the core of your brain's electrical activity are neurons. You have about 86 billion of them, and they communicate using a combination of electrical and chemical signals. Neurons, also interestingly enough, have a different electrical charge on the inside and the outside of the cell. This charge is maintained by sodium and potassium ions, which move in and out of the neuron. But when a neuron gets a signal, everything changes. This is called an action potential. An electrical impulse that travels down the neuron, allowing it to send messages. It's a rapid, all-or-nothing event that makes everything from thinking to moving possible. But neurons don't work alone, they need to communicate with each other. And that happens at connections called synapses. When an electrical impulse reaches a synapse, it triggers the release of neurotransmitters. You might be familiar with those in, for instance, antidepressants, right? Serotonin neurotransmitters, neuroepinephrine, and so forth. So these tiny chemical messengers help transmit signals from one neuron to the other. Sometimes it excites the next neuron, making it more likely to fire, while others will inhibit, reducing their activity. This delicate balance controls everything, and this whole thing happens at incredible speeds. Neurons can fire hundreds of times per second, generating the electricity that powers the body as a whole. The brain powers up our nervous system, running signals all through our body like roads inside of a city. Our brain sends signals to our nervous system and it will pulse and tell our body what it wants it to do. Without these electrical impulses going off, we couldn't watch this video, stand up straight, react to pain, eat, or even have a heartbeat. Now, we don't just produce electricity, but also heat. These are two things our body no longer has when it has died. So let's go over that really quickly. Our body, a furnace. Have you ever wondered how our body keeps warm even when it's freezing outside? Unlike machines that rely on external heat sources, your body generates its own warmth through fascinating biological processes. The primary way your body generates heat is through our metabolism, and that's, us converting food into energy. When we eat, our body breaks down carbohydrates, fats, proteins, etc., turning them into usable energy. And the interesting part is this energy conversion isn't 100% efficient. And some of that energy is released as heat. Even when we're just sitting down or sleeping, our body's constantly working, breathing, pumping blood, repairing cells. This baseline level of energy use is called the basal metabolic rate, and it accounts for the majority of our body heat. And if you've ever gone to the gym, started working out, you know how your body heats up. But that's because our muscles are heat-generating powerhouses. When our muscles contract, they use the energy from the food that we've eaten, and as a result, produce heat as a byproduct. In fact, about 75% of the energy used by our muscles turns into heat. That's why just after a few minutes of exercise, our body temperature rises quite a bit. Also, when our body senses cold temperatures, it has a backup plan, which is shivering. This is an involuntary process where our muscles contract rapidly to generate heat, because our muscles generate heat the best and the fastest. You can think of it as sort of like a built-in space heater inside of our body. Shivering increases heat production up to 5 times the normal rate. And how does our body know when to produce heat? Well, now we go back to the brain. The hypothalamus sends signals, electrical signals, to our muscles to shiver, blood vessels to constrict, to keep heat in, and our metabolism to ramp up. It's our body's natural thermostat. Now, we're talking about how our body has energy, and that's through electricity that's inside of us, but also heat that we generate. And there's a law regarding energy. So let's get into the physics. Law of the conservation of energy. Energy is all around us. It powers our cars, lights our homes, and even fuels our bodies. But did you know that energy is actually never created or destroyed? It only changes forms. This fundamental principle is known as the law of conservation of energy, which is the first law of thermodynamics. Thermodynamics is a branch of physics that deals with heat, work, and temperature, and their relation to energy, entropy, and the physical properties of matter itself. The takeaway message of this law is, energy cannot be created from nothing. The only way to use energy is to transform energy from one form to another. Imagine a roller coaster. When it climbs a hill, it converts kinetic energy into potential energy. When it falls, that potential energy turns back into kinetic energy. So the total energy remains the same. It just changes its form. And it's not just science, but happens all around us. For example, a person eating food converts chemical energy into kinetic energy for movement. A car engine converts chemical energy from fuel into thermal and kinetic energy to make the car move. A hydroelectric dam uses gravitational potential energy transformed into kinetic energy, and then electrical energy, which we use to power our homes. Energy is always on the move, shifting from one form to another, but never disappearing and never being destroyed. This law also has some different sub-rules depending on if the system is closed, open, or isolated. I'm just going to show you a clip from Arvin Ash that I think explains these systems really well.
There's sometimes some confusion about isolated system versus closed system. In thermodynamics, an isolated system is one in which no energy or matter can enter or leave. A well-insulated thermos would approximate an isolated system, but there's no perfect isolated system we know of. A closed system is one in which no matter enters or leaves, but energy can. A covered pot or cup of tea would approximate a closed system.
The law of conservation of energy is one of the universe's fundamental principles. It governs everything from the smallest atom to the largest galaxy. Energy is never lost, it just transforms. And since we have energy inside of us, it can't be destroyed, so where does it go? And that's what we're going to get into. But first, I want to talk about another law that plays a role in all this. The law of conservation of mass. The law of conservation of mass states that the total mass should be a constant inside of a closed system that does not allow matter or energy to escape. This is a law of classical mechanics, which is still within the study of physics. The law of conservation of mass and the law of conservation of energy ended up getting unified into the principle of mass-energy equivalence as described by Albert Einstein's equation, E equals mc squared, which most people are familiar with. As well, this led people down to the theory of special relativity, which is a theory of the relationship between space and time, and it also redefines the concept of mass and energy together. Essentially, special relativity shows that mass and energy are related to one another. They balance each other out. And all of this led into the theory of general relativity, which is the geometric theory of gravitation by Albert Einstein. Why I'm bringing all this up is because some of you might be asking, what about the expansion of the universe? Isn't the energy dissipating with it? And this is an interesting side tangent, which I will touch on briefly. Dark energy. So, energy has different systems, and it was always thought that the universe was an isolated system. Therefore, we shouldn't be losing any mass or any energy. But that's been called into question. And now quantum science is trying to answer the problems that we're facing with the universe not fitting within these laws. I find quantum physics very interesting, and I do feel like the quantum world is going to be where we find answers to the paranormal. So I want to touch on this a bit, as future episodes in the show I will be delving into the quantum world as well. But specifically to do with energy in the universe, we go back to 1912 to 1914. Vesto Slipher discovered that light from remote galaxies was redshifted, a phenomenon later interpreted as galaxies moving further away from us, or you may be familiar with the universe expanding. I won't go into the detail of the history of the study of redshift, but suffice to say that both the Hubble telescope confirmed it, and now the James Webb telescope confirmed that the universe is expanding even faster than we originally thought. So why is this an issue? Well, science had always considered the universe to be an isolated system. However, when the red light shift was discovered, that seemed to throw the conservation laws out the window, as it's essentially showing that the light, aka energy, is dissipating and dying over distance. But in actuality, scientists believe that the laws are not broken. They believe that the energy that is dissipating is actually turning into dark energy. Dark energy is a mysterious force that is thought to be responsible for the accelerated expansion of the universe. Although we can't directly observe it, scientists have inferred its existence from the way galaxies move and how the universe is expanding. Dark energy has a repulsive effect on the fabric of space itself. It's thought to make up about 68 or 69% of the universe, and matter only makes up about 5%, and the rest is dark matter. So unlike matter, which pulls things together through gravity, dark energy pushes things apart. Dark energy is one of the biggest mysteries of modern physics, and it remains largely theoretical because we don't know exactly what it is or how it works. We can't observe it. It's one of the key subjects of ongoing research in cosmology right now. It's such an interesting problem to solve that people are actually attacking it from various angles and ideas. I won't go into detail on everything being studied for dark energy, but if you want to read more, you can check out loop quantum gravity, white holes, Greenberger-Horn-Zellinger paradox, or GHZ paradox, and also there's an article called Limits on the Number of Space-Time Dimensions from GW170817. I know this is a weird name, but anyway, I've added some links to some of these things in my reference link as well if you guys want to read more. There's so many theories and studies being done on dark energy, we're going to have to keep an eye out to see what they discover over time. All right, now that you understand the laws and you understand how energy is working even within the universe itself, let's revisit life after death. The soul, life after death. Okay, so to start, let's apply the law of conservation of energy to the body. Even though day to day looking at the body, it seems like it's a closed system, the body's actually an open system. We can control the loss of mass, for instance, diets, food, exercise, or we can stay relatively the same mass for some time until we start aging, then our body starts to break down and we lose mass from aging, disease, whatever it might be. So according to the law of conservation of mass, everything must even out by weight of what goes in and what goes out. So what if we could weigh the soul? Well, that's what someone thought to do back in 1907 with an experiment. The 21-gram experiment. This is an interesting story, so I wanted to throw it in here for you guys. The 21-gram experiment was a controversial scientific study conducted in 1907 by Dr. Duncan McDougall, an American physician. He attempted to measure the weight of the human soul by weighing people at the moment of their death. McDougall got 6 terminally ill patients on a specialized scale designed to detect even the smallest of weight changes. He measured their weight before and after death to see if there was any loss. In one case, he recorded 21-gram loss at the exact moment of death. He then concluded that the soul must have a physical weight of 21 grams. Later, he repeated the experiment with dogs, finding no weight loss, which he claimed supported the idea that animals do not have souls. Now, McDougall's experiment has been widely criticized for flawed methods and a small sample size. Only 6 human subjects were tested, which is statistically insignificant. Not all of them showed the same weight loss, too. Even though he has this 21-gram, others actually weighed different. External factors like sweat loss, air leaving the lungs, bodily fluids can explain all these weight changes. The scale itself also back then wasn't actually precise enough for these small measurements either. Despite its flaws, the 21-gram experiment gained popularity and became part of popular culture. The idea was referenced in the 2003 film 21 Grams, which explores themes of life, death, and the soul. Also, some spiritual and paranormal beliefs still reference it as evidence of the soul's existence, even though it's flawed evidence. But the one that I find most interesting is in an episode of Evil, the TV show. They actually revisited this experiment with modern day stuff. And it's very interesting. They go in, they're in a controlled environment, and they put this person essentially in like a controlled environment coffin, and nothing can escape it. No like air, no nothing, whatever. So I'll see if I can put a clip of it here, but it might get copyrighted. But essentially there was a priest who was dying, cancer or something, can't remember. And then he went to the coffin to do the experiment because he agreed, because the church is like, yeah, if we can prove there's a soul, yeah, that looks good for us. So they put him in this thing, and it's like hermetically sealed essentially. And it has like sensors and cameras and everything. He ended up passing, and then I think a bunch of electricity went. They didn't say it, but they show with cinematography and the effects that the soul couldn't get out of the box. So it just went back into his body. And then they open up the thing and he's still alive, and then he carries on living. So he got a second life through this box. It's really interesting, the spin that they took on it. That show is very good, by the way. I do recommend it. So yeah, I'll try to put a clip of it in here. And if the clip doesn't go, then at least I explained to you the description of what happened in case the clip ends up ever being deleted from the video. So while the 21-gram experiment lacks scientific credibility, it remains a fascinating example of how people have tried to bridge science and spirituality. But how about we just look at the simplest answer? Transformation of energy. Now, this one to me, I think is the simplest answer. And I do think that this is more what I believe. I do believe when we pass, we have electricity in us, we have energy in us. Maybe it's some sort of spirit essence or soul, but I think that we just get recycled back into the system. And maybe we get reborn as a tree. Maybe we get reborn as a person. Maybe we get reborn as whatever, an ant. I think in the end, all the energy is interconnected. And this is sort of the theory that I think. You can't destroy energy. So I don't think that we're just gone. I don't think we're nothing after we die. But I do think that we just go back into the system. Do I believe in reincarnation? Maybe. Our lives are so short, it would make sense if we get reborn into different lifetimes to experience different things. Because life isn't supposed to be about working and struggling financially and all that. We created that prison of money and the economy ourselves. Life is supposed to be about experiencing things, experiencing the world. And I think a lot of people too just imagine that life is like a human. Whereas I have always thought, there's probably intelligent life in a nebula, but it's in the form of a gas or an electrical signal, and we can't comprehend it, so we don't know how to communicate with it. So I think even when we pass, that we could even be reborn as something in space on a different planet, whatever. I think anything's really possible of where our energy might end up. But yeah, that's sort of a theory, I guess, that I have, and it's kind of evolving over time as I think more on it. Now, I've been really concentrating on the energy and electricity part of our body, where it goes, but what about consciousness? After all, that's what is said makes us human, our spark. Consciousness and the quantum world. While there are many theories on our consciousness moving into other realms, these theories all reside in the world of spiritual belief. But what happens when science tries to step in here? Well, we end up with theories that are from the quantum world. It is interesting because I've found multiple scientists are tackling proving the brain and consciousness is quantum. They're all over the world from different countries and stuff, and they're all saying very similar things because the math is working. And that I do find fascinating. Okay, to start, the one that I found really interesting, I actually just found the other day. There's CPU inventor and physicist Federico Fagan working with Professor Giacomo Moro Dariano, and they propose that consciousness is a fundamental aspect of reality itself, and quantum fields are conscious and have free will. And their theory, essentially, is that our body is a machine and we drive it like a car with our consciousness that actually exists in a quantum field. I'm going to play you a clip of this where they explain it a little bit better. I just simplified it there. He calls this theory quantum information panpsychism, or QIP. So he believes that this will be able to give us actual testable predictions in the near future as well. I just found really resonated with me for this particular topic for this video. So check it out.
Imagine that you control a drone. The drone looks at that reality where it is, sends me information, and I get the conscious experience of what the drone is seeing. That conscious experience is not in my body, it's in my consciousness.
A scientific theory that basically states that our body is operated like a drone from a conscious quantum field, which would mean that experience, qualia, is not in your head.
The qualia do not exist in the body, they exist in the field.
Okay, people will find this crazy idea.
It is crazy, but it is much closer to the truth.
Federico Faggin invented the first CPU, the touchpad, and worked on the first neural nets, which gave him the hope of creating conscious AI.
It took me 30 years to figure out that mathematics is created by consciousness, and therefore I cannot explain consciousness with mathematics. Many physicists think that there is emergent properties in the purely classical world. It cannot be. Emergentism requires quantumness.
Like some other renowned physicists, Faggin is convinced that consciousness cannot be a classical phenomenon and has to be quantum. But his theory of quantum consciousness goes beyond any theories on the table.
We have to go way beyond Schrödinger's equation. We had to go into Dirac's equation, but even beyond that, we had to go to quantum fields and quantum information. And quantum information goes beyond the concepts of quantum fields. In fact, the only physicist that has been able to show that quantum physics derives from quantum information is an Italian physicist, Giacomo Mauro Dariano. He showed that you can derive all the equations of quantum physics from quantum bits.
Federico Faggin reached out to Mauro Dariano, and together they published a paper, and Federico wrote this book. If they are right, not only will they have an accurate theory of consciousness, they will also solve the mystery of the interpretation of quantum mechanics.
Quantum information is the representation of inner experience, and the collapse of the wave function is the representation of the free will. What more do you want?
I did find a paper by Roger Penrose and Stuart Hameroff, and their paper the objective was to explain consciousness through quantum mechanics. Their hypothesis is consciousness originates at a quantum level inside the brain neurons, inside microtubules. And they said that if this is true, consciousness could exist independent of the body, suggesting a possible scientific basis for the soul. Now, I pulled together pieces from an episode from Anton Petrov where he explains this paper in a better way than I'd be able to explain it. I find this whole video fascinating, so I will link everything, but go check out the entire video as well. I do suggest that you go and watch this video in full, as these are complex topics and it does explain it in the whole video.
The researchers discovered something really unusual by building a network out of a protein known as tryptophan, and that something starts to produce quantum effects. But to understand all of this, let's go back a few decades when the famous Nobel laureate Roger Penrose proposed something that a lot of people thought was maybe a little bit too much. And here he tried to explain consciousness by trying to bring in quantum mechanics, but also mixing this with his field of study in general relativity, quantum superposition, and even space-time curvatures. And so he essentially proposed that our brain is able to produce quantum states inside that are then collapsed by things like, for example, gravity, but this unusual view was basically criticized by everyone. But then someone else read his book and actually added his own ideas. This is Stuart Hameroff, a professor at University of Arizona who specialized in anesthesiology. He discovered that a lot of different anesthetics tend to be very strange gases that don't make sense and should not act on neurons. He proposed an intriguing idea. He realized that maybe all of this is actually the result of interaction between tryptophan rings and various chemical compounds. It can sometimes form complex structures that eventually form rings. And it's really the formation of these unusual rings or these strange tunnels that could be responsible for everything. And so here Hameroff proposed that anesthesia works through the interaction with these unusual microtubules when certain anesthetics, such as, for example, xenon, bind to various tubulin molecules, occupying them inside, which then changes the frequency of vibration that a lot of these structures produce naturally. These unusual tubulins are literally everywhere inside of us. Their main function is basically structure. For example, there's that famous video that went viral a while back that shows us a tiny protein known as kinesin literally walking on microtubules, almost like roads inside a typical cell. But what makes these structures somewhat unusual is really the fact that they form these very strange cylinders, and actually cylinders that are extremely orderly, that sort of create almost like crystals. And so when Hameroff discovered about microtubules, he realized that they have a very high chance of being responsible for what makes us conscious. And he even went further and argues that microtubules provide computation inside our brain, and so he actually proposed to Penrose that this was the basic unit of processing inside neurons themselves. Not the connection between neurons, but microtubules inside neurons. And so naturally this idea of tubules or microtubules was a very contentious proposition, and pretty much everyone disagreed with it. But it didn't stop Penrose and Hameroff, and they eventually proposed a new concept. They refer to it as orchestrated objective reduction. So yeah, all of this might sound super complicated, and it really is, but if I were to give you a 5-second explanation, it's basically as follows. Brains contain microtubules. Microtubules form complex crystalline structures that can somehow produce quantum states inside of them. Those quantum states create these really large quantum waves inside the brain that collapse for various external reasons that somehow leads to the idea of consciousness.
Now, the next one that I want you to check out is Rupert Sheldrake, and he discusses if our mind is able to affect things outside of our body. Now, this theory is, for instance, if you stare at someone, eventually they'll turn around and they just know where you are, right? This has been studied quite a bit, and I know that it has been sort of disproven, or more like there isn't enough proof that it's out there, but I think it's something that you have to train your body to do, because it's something that I was trained to do when I was in ninjutsu. So I was in martial arts, and it's something that we did. Like, you kind of just calm your body, kind of go into a meditative state, and you figure out where someone is in the room and they're staring at you. So like, I think it's something we can do, but I think it's something where we're like feeling some sort of energy, maybe some sort of waves in a certain pattern that are coming off of each other. But it's hard to do if like you're in a crowded area. But apparently he says that it happens randomly to people. I just find it really fascinating as a talking point, but do take it with a grain of salt because it has been disproven. I will play a little bit of a clip of a talk that he did. As well, with Rupert Sheldrake, he has some very interesting ideas. He has a YouTube channel too, which I'll link. But he does get very religious, which I think kind of pushes some of his ideas out of the scientific community. So watch his stuff, take it with a grain of salt.
The great Greek geometer Euclid, around 300 BC, pointed out that vision is an active process. If you're looking for a pin and suddenly you see the pin, what your experience changes because you've now identified where it is. It's an active seeking, and now it looks different once you've seen and recognized the pin. The gravitational field of the Earth is in the Earth, but it extends far beyond it. The reason we're not floating in the air at the moment is because it's holding us down to the ground. It's invisible. This room is full of it, but we can't see it. It holds the moon in its orbit. It stretches far beyond the Earth. This room is full of radio transmissions from mobile phones, from radio and television programs. The world is full of invisible fields. This is a revelation of 19th and 20th century science I don't think has been taken on board by people thinking about materialist theories of the brain. And what I'd like to suggest is that our fields of our minds stretch out far beyond our bodies. They stretch out invisibly, and our consciousness is related to and based on these fields. The easiest way to see what I'm talking about is indeed through vision. But the mysterious part is then what happens next. How do you create images, three-dimensional, full-color images, which Aniel calls controlled hallucinations? How does the brain create those? They're all supposed to be inside your head, representations of the outer world. So I can see you sitting there, you can see me here, but all of you are supposed to be inside my head, as lots of faces and the whole of this room is meant to be. And inside your head is supposed to be a little Rupert somewhere inside your brain. That's not what we actually experience. What we actually experience is that our images are out there. Your image of me, I'm imagining, is where I'm actually standing right now, and my image of you is where you are. Another and older theory of vision, the extramission theory, that says not only does light come in, but the images we see are projected out. So my images of you are where they seem to be. They're in my mind, they're in my consciousness, but they're not inside my head. They're where you're sitting. Developmental psychologist Jean Piaget showed that young European children think that they're projecting out images, that they take it for granted. So this is in fact a very deep-seated way of thinking about vision. Arvid Gutterstam, working first at Princeton University, now at the Karolinska Institute in Stockholm, has shown that by some very ingenious experiments that people attribute a gentle force to the gaze as it goes out of the eyes. They've even shown, using fMRI, that regions of the brain involved in tracking movement are activated. And as he puts it, the results, this is a quote, strongly suggest that when people view a face looking at an object, the brain treats that gaze as if a movement were present, passing from the face to the object. And they found that this occurred even in people who didn't believe in visual extramission. It's deep, hardwired in the way we see. And they tried to explain this by saying there must be an evolutionary reason for it, and this leads to the illusion that something's going out of the eyes when you look at things. It would make much better sense in evolutionary terms if it's not an illusion, but if it's real. And so is it real? Well, you're not meant to think it's real because that goes against the dogma that the mind is nothing but the activity of the brain and the perceptions are inside the head. Is it testable? Well, I think it is. If when I look at you as a projection from my mind that touches you, my mind in a sense reaches out to touch you. If I look at you from behind and you don't know I'm there, could you feel that I'm looking at you? Well, as soon as you ask that question, you realize that the sense of being stared at is very common. It's now called scopaesthesia, the scientific name for it. Scop as in microscope, seeing, aesthesia, feeling, as in synesthesia, anesthesia. Scopaesthesia is extremely common. Most people have experienced it. I'm sure most people in this room have experienced it. You turn around, you find someone's looking at you, or you stare at someone and they turn around and look back. Doesn't happen all the time, but it's very common. Most people have experienced it, including most children. It's usually directional. You turn and look straight at the person. You don't just feel uneasy and search around. Questionnaires, we find it typically happens most powerfully with strangers, often with male strangers in situations that could be vaguely threatening. We've done interviews with more than 50 surveillance officers, celebrity photographers, and private detectives, practically all of whom just take this for granted. If you've ever trained to be a private detective, and I'm guessing that most of you haven't, you will have learned that when you're following someone, shadowing somebody, you don't stare at their back, because if you do, they'll turn around, catch your eyes, and your cover's blown. You have to look at them a little bit, otherwise you lose them, but you look at their feet. In the martial arts, it's taken for granted, and they have methods of training people to become more sensitive, because if you can feel when someone's approaching from behind who might attack you, you'll survive better than if you didn't feel it. They train this ability, people get better at it. And I think it has enormous implications for our understanding of the mind, because if our minds are not just about what happens in brains, and if our conscious experience is extended through electromagnetic fields, which is what light is, it suggests that minds have an interface with electromagnetism. We know they do in the brain. A lot of brain activity that correlates with consciousness is electromagnetic activity. There seems to be an interface between electromagnetism and consciousness, and why it should be confined to the inside of the head is a purely arbitrary assumption. The official view is it's all inside the brain, but I don't think it is. And so I think once we liberate the mind from the brain more generally and consciousness from the brain more particularly, we have a much wider context for discussing this knotty problem, the hard problem of the relation between mind and brain.
All right, let's get into some final thoughts. Whether seen as an eternal spirit, an aspect of consciousness, or a poetic expression of identity, the soul remains a profound mystery. It's a question that continues to inspire faith, philosophy, and scientific inquiry. So like I said at the beginning, the idea with this show is to discuss theories for fun. Remember, none of this stuff is proven, but it's a fun thought exercise and discussion topic. It is something humans have done for eons, debate and question what happens after life. So tell me, what do you think about life after death, the soul, or our energy inside of us? Leave a comment below and let me know. I want to know your thoughts. Also, let me know what you think about this type of show. I'm trying some new ideas this year, so, give me any feedback that you have. As well, with my startup new shows, there's going to be a little bit of like changing them up and growing pains with it too, but I'm looking forward to any of your feedback as well. And to end off this video, I just want to thank all my members and patrons. Your support does mean a lot, and it does help with making these videos as well. I do appreciate it. All right, well, I will talk to you guys next week when I'm going to be getting into the Lindley Street poltergeist, so it should be interesting. I'll talk to you guys then. Bye. Don't worry about what to watch next because I have linked a video, or if you want to sit and watch things for a little bit longer, a whole playlist on the side here. Go ahead and click those now to keep watching.